today's session, and this is a problem solving session of Magnetostatics. Today I will discuss the tutorial question bank, model question paper, old question paper and some gate problems. Myself Dr. Sayanti Chatterjee, Associate Professor of EEE Department of IARE College. So I will start with my first problem. Steady state current I amperes flows in a conductor bent in a circular. So we have a current carrying conductor, it is in a circular form and a steady state current I is flowing. Find the magnetic field at the center of the loop. So we can use here the formula of we have to calculate the magnetic field H at the center. So what we will use here? We will use here Biot-Savart's law. And what is the Biot-Savart's law told? Biot-Savart's law told DH or H is equal to magnetic field intensity can be written as integration of I dl sin theta by 4 pi r square. I dl sin theta by 4 pi r square. So I is constant, 4 pi r square is constant, and in a circle the theta is the angle between the the perimeter and the center, and it is always for a circle theta is always 90 degrees. So we can write I 4 pi r square integration of dl. Now in the case of a circle, the dl is the length and it is nothing but the 2 pi r. So we can write I by 4 pi r square into 2 pi r. Pi cancel out r and 2. So it comes I by 2r, and this is for a number of turns is 1. If number of turns is equal to n, so what will be the value of h? H is equal to ni by 2 pi r. We can write ni by 2 pi r. So this is the current. So if we use this formula, H is equal to ni by 2r. So what is n here? So we will get the steady state current I amperes flowing in a loop is H is equal to ni by 2r. What is B? B is equal to mu H, and so we will get B mu ni by 2r, or we can write it like mu naught mu r ni by 2r. This is the H. What is the direction? Direction is always radial. So we got the problem 1. Now I will move to the next problem, which is the problem 2. A circular coil of radius of 1.5 centimeter centimeters carries a current of 1.5 amps. If the coil has 25 turns, find the field. So field means flux density. So first we have to calculate the H. What is H? Ni by 2r. We have discussed in the just previous slides that H is equal to ni by 2r. Here I is given as 1.5 amps. What is N? N is given as 25 turns. And what is the value of R? R is given as 1.5 centimeter, which can be written as the 1.5 into 10 to the power minus 2 meter. So what is H? H is equal to 25 into 1.5 by 2 into 1.5 into 10 to the power minus 2. What is the unit of H? H unit is ampere turn per meter. So what we will get here? 1.5, 1.5 will cancel out. So it is 12.5 into 10 square ampere ton per meter. We got the value of the H. H is equal to 12.5 into 10 square ampere ton per meter. And if we get the value of the H, we can get the value of the B. And what is B? B is equal to mu naught into H. Mu naught is equal to 4 pi into 10 to the power minus 7 into 12.5 into 10 square, and the unit is Weber per meter square. The unit is Weber per meter square. So it is coming like 50 pi into 10 to the power minus 5 Weber per meter square. We can write like Tesla. So this is our problem number 2. We have the formula H is equal to Ni by 2R. N value we got, I value is given, and R is the 1.5 centimeter, which can be written as the 1.5 into 10 to the power 10 to the power minus 2 meter. So what if we put the value, we can calculate the H. H is ampere ton per meter. What is B? B is equal to mu naught H is equal to 4 pi into 10 to the power minus 7 into 12.5 10 square, means 50 pi into 10 to the power minus 5 Tesla. Now we are moving to the problem number. A steady state current of I amperes flows in a conductor bent in a form of square loop of side A. Find the magnetic field at the center of the loop. So what is this? This is a and all the sides are A. All the sides are A. So we have the like this, we have the conductors. We have to calculate the field at the center edge. So how to get this equation? Again, we got that the IDL sin theta and current is flowing is IDL sin theta by 4 pi r square. So IDL sin theta by 4 pi r square is equal to H. H is equal to IDL sin theta by 4 pi r square. So what is the theta? The diagonals of this will always create the angle 45 degree. So in one center means one side and two sides. So we can write I by 4 pi r square integration of dl sin 45 degree. What is the and into we can calculate either for 2 or other for 4. So it is coming 4 cancel out. I by pi r square dl sin 45 degrees nothing but the 1 by root 2 and integration of dl. So I by root 2 pi r square dl is equal to 4 into a. So if we calculate this, we can get the value of the H. And what is B again? B is equal to mu H. So mu value we don't know. Mu value is mu naught mu R into H. So if we put the value, we can calculate the value of the B. So this is our problem number 3. We have a squares. So the conductors are on this and the angle is 45 degree. A uniform solenoid in a diameter of 100 meter in diameter and 400 meter is long. The current is flowing I. Find the magnetic field on the axis of the solenoid at the center at the end. So there is a uniform solenoid and it is 400-meter long. Number of turns is equal to 100. Current I is equal to 3 ampere. So what is the H? H is equal to Ni by length, ampere turn per meter. So at the first we will do at on end. End means the total length. So N is 100. I is current is given as 3 amperes. And what is L? L is the 400 meter. 400 millimeter. So millimeter means 0.4 meter. So if we solve it, we will get so this is the at one end. At the halfway. At the halfway. What is the meaning of the at the halfway? At the halfway means when the length is half. So at the halfway means H is equal to Ni by L by 2. So it will come 2 Ni by L. Ni by L already we got 750. So we will get 1500 ampere turn per meter. Now we have to get the at the center. What is the meaning of the at the center? If we think this is a circle, all the at the center of each circle, if this is a solenoid, there is some circular path, and at the center means not the halfway, center means at the midpoint, and for the midpoint H we are now doing, this is the question number B, this is our question number C. Now we are doing the H. See H is equal to Ni by 2R. So what is the N again? N is number of turns is 100. I is given as 3 ampere. 2, what is the R? 100 millimeter in diameter means 100, sorry, 0.1 by 2. So 2 to cancel out, and we can get the value at the center. So this is our question number A. So center means if we see the top front view of a solenoid, we will get a circle. So at the center of the circle there are 1000 turns. How much is the field intensity, and the formula is Ni by 2R is equal to 100 into 3 into 2 into 0.10 by 2. So we have completed the problem number 4. Now we will move to the problem number 5. So a current of 1 ampere is flowing in a circular coil of radius 10 centimeter and 20 turns. Calculate the intensity of the magnetic field at a distance of 10 centimeter on the axis of the coil and at the center. So this is our problem number 5. A current of 1 ampere. A current of 1 ampere is flowing in a circular coil of radius 10 centimeter and 20 turns. Calculate the intensity of the magnetic field at a distance of 10 centimeter on the axis of the coil and at the center. So what is in the question? There is a current of 1 ampere. of the radius of 10 centimeter. Radius of 10 centimeter. Now, calculate the intensity, means we have to calculate only the H, not the B. Calculate the intensity of the magnetic field at the distance of 10 centimeter on the axis. So, if we check in the axis, another point at, this is the P point, 10 centimeter, we have to calculate the axis of the coil and at the center. First, we will know the at the center formula. What is the formula of the at the center? H is equal to Ni by 2R. So, what is N number of turns is given 20 turns. What is I? I is given as 1 ampere. I is given as 1 ampere by 2 into R. R value is given as 10 centimeter. 10 centimeter means 0.1. So, it is coming 10, 100, ampere turn per meter. So, this is the H. Now, we will calculate the P. So, P is on the axis and it is 10 centimeter. So, we can think the value of this X is 10, 0, 0. What is the value? 0, 0, 0. So, what is the distance we can write? We can here, if we use the Biot-Savart's law, in the Biot-Savart's law means H is equal to I. We can also write like this, 4 pi r square. Ideal sin theta, we can write like dl cross AR. What is AR? AR is the distance of this. DL is the radius. And what is the radius value? The radius value is also 0, 10, 0, 0. We can take it as the 0, 0, 10. So, if we put the value of the DL cross AR, we will get the equation. What is the DL then? DL is equal to 0, 0, 10 means only 10 isn't. What is AR? AR is equal to 10 arrow. So, if we solve this, we do the cross product. The value will come like I r square n I r square 2 pi r square plus x square of 3 by 2. 2 r square 2 r square by x square 2 by 3 by 2. So, what is the number of turns? Number of turns is 20. What is the value of the current? Current value is 1 ampere. What is the value of R? R value is also 10 centimeters, means 0.1 by 2. 0.1 square plus 0.1 square by 3 by 2. If we put the value, we can calculate the value of the H. Now we are moving to the problem number 6. State the Biot-Savart's law and gives the point C is equal to 5, 2, 3 and P is equal to 4, 1, 2. A current element IDL is equal to 10 to the power 4, 4AX plus 3AY plus AZ ampere at C produces a field DH at P. Find DH. So, first we have to tell the Biot-Savart's law. What does the Biot-Savart's law tells? That if there is a current carrying conductor, the current flowing through is I. This is a point P and the distance is DL. Distance is dr and the current flowing in a small section is IDL. then we can write H is equal to I dl. H is directly proportional to I dl. The H at the point P, H is the magnetic field intensity, is directly proportional to 1 by r square, or this is the r, and H is directly proportional to the sine theta, the angle between the point P with the current carrying conductor. And if we combine these three equations, we will get H is equal to, H is directly proportional to I dl sine theta by r square. So H is equal to I dl sine theta by 4 pi r square. Now, if we go for the electric field intensity, magnetic field B, B is equal to mu H is equal to mu I dl sine theta by 4 pi r square. We got the value of the B. B is equal to, so this is the vector form of the, this is the scalar form of the Biot-Savart's law. Now, if we want to write the vector form of Biot-Savart's law, what is the vector form of Biot-Savart's law? We can, this is the scalar form, this is the mod of B, mod of mu H. But if we want to write the vector form, so we can write dl sine theta, we can rewrite as dl into 1 into sine theta. So dl is the length vector dl. What is 1? 1 is nothing but the AR. AR sine theta. So AR is the distance. AR is the unit vector according to the distance. So if we write that we can write the dl mod of dl mod of AR into sine theta. So it is like AB sine theta. So we can write dl cross AR. So what is the value of H then? H value will be modified as H is equal to I. These are all DH, not H. This is the DH. We are taking the very small value. So what is that ADH? DH is equal to I dl cross AR by 4 pi r square. So we got the value of DH. So this is the Biot-Savart's law. And in the vector form, if we want to calculate the total H, it will be integration of I dl sine theta by 4 pi r square. So this is the Biot-Savart's law. Now we will move to the second part of this problem. Given point, say it is a current carrying conductor, the current I dl is flowing. We have to, this is the value of this small area is 5, 2, 3, and another point is P. P is equal to 4, 1, 2. So what we have to do first? We have to calculate the value of this radius. So that we are calculating the intensity from the point C to P. From the point C to P. So what is the equation of the line CP? End point minus starting point. End point minus starting point. 4ax plus ay plus 2az minus c is 5ax plus 2ay plus 3az. So what is the value? Minus ax minus ay minus az. What is the mod of Cp then? Mod of Cp then root of 1 square plus 1 square plus 1 square. So it is root 3. So we got the value of the Cp. Then what is that? So this is our radius. This is our radius. So what is AR? AR means the unit vector. What is AR? AR is the R by mod of R. So what is R? Minus AX minus AY minus AZ by root 3. We got the AR. So this is the first topic. Then we have to calculate the DH. What is the value of DH? DH is equal to IDL cross AR by 4 pi r square. So 4 pi ideal value is given in the problem 10 to the power 4 4ax plus 3ay plus az. What is the value of AR? AR is equal to, we have calculated my cross product minus AX minus AY minus AZ divided by, we are getting the distance 4 pi r square is 3. So by 12 3. So here we have to do the cross product. If we complete the cross product, we can calculate the value. So how to do the cross product? So now we want to do the cross product. So how to do the cross product? The cross product we can do AX, AY, AZ. What is the value of ideal? 10 to the power 4 into, I am taking it in the outside, 4ax plus 3ay plus az by, there is AR has 1 root 3, actually I missed this, by root 3 minus 1 minus 1 minus 1. So if we take the determinant of this, what is the determinant? 10 to the power 4 by root 3, 4 minus 3 plus 1 minus 3 minus 4 plus 1 plus 1 minus 4 plus 3. If we solve this equation, we can get the value of this cross multiplication, and after that we can calculate the total value of the Biot-Savart's law. So this is one important problem we discussed here. First one is the Biot-Savart's law, and then we will discuss about the Biot-Savart's law in the vector form, because if we don't use the vector form, then we cannot solve the problem. Next, we have discussed about the problem 6, the procedure, how to calculate the DH. But remember one thing here, we are calculating the DH, not the total H. So this is our problem number 6. Next, we will discuss the problem number 7. What is the problem number 7? The magnitude of H at a radius of 1 meter from a long linear conductor is 1 ampere per meter. Calculate the current in the wire. So this is a small problem, very small problem. H is given as the Ni by 2R. So what is I? I is given, or Ni by L. Better to write Ni by L. Ampere turn per meter. So what is H? H is given as the per meter. It is 1 ampere. So H is equal to, now I is equal to H by N. H by N. So the magnitude is the 1 meter from the length, and the H is equal to 1 ampere per meter. So what is I? I is also 1 ampere. So this is a very very small problem. H is equal to given 1 ampere per meter. N is not given, means number of turns, so we will take 1. So L is also given 1. So I is obviously it is 1 amps. So this is my today's now lecture. So up to this I have discussed now. I will discuss the other problems in my next lecture, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.